This video will be going over complex numbers. Alright, to define it, a complex number is, complex number is any number that can be written in the form a plus bi, with a and b being real numbers. This number here, whatever a is, that's what we call the real part. And this part bi, that's called the imaginary part. And this form a plus bi, that's what we call the standard form. Alright, we're going to do some examples of, various things we could do with imaginary numbers. First thing we're going to go over is adding and subtracting. In case you don't remember from previous classes, if you're adding complex numbers, you just add the real parts together. In this case it would be a plus c, then add the numbers in front of the I. So with that in mind, let's do a few examples. Alright, the first one is 4 plus 3i plus 5 plus 9i. Alright, if we add the real parts together, 4 plus 5, that would give us 9. And if we add the imaginary parts together, 3i plus 9i, that would give us 12i. Alright, the second one we're doing is negative 6 plus 4i plus 8 minus 7i. Alright, if you add these together now, negative 6 plus 8 would give us 2, then 4 plus negative 7, or 4i plus negative 7i. That's the same as 4 minus 7, so that would be minus 3i. Those are your answers, and I got one more. Our last example, 1/2 plus 3/4 i plus 2/3 plus 1/5 i. Alright, I'm going to be a little bit more detailed with my work because we're adding fractions with different denominators. So we would add the real parts, 1/2 plus 2/3, then add the imaginary parts, 3/4 plus 1/5 I. Now you need to get these into a common denominator. For the real part, that common denominator would be 6. So multiply the top and bottom on 1/2 by 3, multiply the numerator and denominator 2/3 by 2, so you would have 3/6 plus 4/6 plus, and then for the imaginary part, the common denominator would be 20, so multiply the top and bottom by 5. Of the 3/4 by 5, multiply the top and bottom of 1/5 by 4, so you would have 15 over 20 plus 4 over 20 I. So now you can combine it. 3/6 plus 4/6 is 7/6 plus, and then 15/20 plus 4/20 is 19 over 20 I. Here's a note I want you to remember. I is equal to the square root of -1 and I squared. Hence, if you square it, would just be -1. Alright, and we're going to do some examples of how you'd use this. Alright, the first example would be the square root of -4. Alright, you can simplify it. -1 times 4. We know the square root of -1 is I, so you can factor the I out, so I times the square root of 4. And the square root of 4 is 2, so your answer would be 2i. Okay, and your square root of -17, again, that's the same as -1 times 17. You can factor out the square root of -1, just call it I, so I times the square root of 17. Then 17 is a prime number. There's no square root, so no perfect square root, so you can just leave it like that. Alright, last one, square root of -24. Alright, let's go ahead and factor that down. As always, factor out the -1, multiply it by 4, and multiply it by 6. When factoring down, we always try to find at least one number that's a perfect square. So again, square root of -1 is I, square root of 4 is 2, and then we're left with the square root of 6. And you can rearrange this, because whenever we have I times a number, we normally like to put the 2 in front, or the number, so it'd be 2i times the square root of 6. Alright, next section is to go over how to multiply radicals with negative numbers the correct and incorrect ways. I'm going to use an example to illustrate this. Alright, so say if we're multiplying square root of negative 4 times square root of negative 9. We already did know from earlier that square root of negative 4 is 2i. Likewise, you can probably deduce that the square root of negative 9 would be 3i. If you're confused on that, ask me during class. So 2i times 3i, or 2 times 3 is 6, I times I is I squared. We know that I squared is just negative 1, so the answer would be negative 6. Now I'm going to show you the incorrect way. Alright, if you go and just multiply them underneath the radical first, you're ignoring the fact that each of them has an I separately. So if you do that, you're essentially ignoring the negative that you would end up on the outside, that you would have on the outside up here. So you'd end up with the square root of 36, which is just 6. And that's wrong because of what I showed you earlier. So with that in mind, let's do some examples. Alright, square root of negative 6 times square root of negative 8. If you factor an I out of each of these, that'd be I times square root of 6. And then square root of negative 8, just so you know, would be I times the square root of 8. And 8 factors down to 4 times 2, so you have 2i times the square root of 2. So you have 2 times I, so that'd be 2i squared. Then square root of 6 times square root of 2 would be square root of 12. I squared is negative 1. Negative 1 times 2 is negative 2. Remember, square root of 12 is 4 times 3. Remember, square root of 4 is 2, so you can move the square root of this to the outside. So you have negative 2 times 2, which is negative 4 times the square root of 3. Alright. Now, when you're dividing, you pretty much do the same thing. You factor the i's out first. I times the square root of 75 divided by I times the square root of 3. The i's cancel out, so you have square root of 75 divided by the square root of 3. And that would reduce to just, you combine them into one radical, square root of 75 divided by 3. Which would be the square root of 25, which would be 5. Alright, now you have the square root of negative 48 divided by the square root of 12. Notice the numerator has a negative square root, so you can factor the I out. Now since you have a radical on the numerator and denominator, you can combine those. I times the square root of 48 over 12, which would be I times the square root of 4, which would be 2i. Now we're going to do some examples of other things. This one is when you're just multiplying complex numbers. You can just FOIL it. 2 times 4 is 8, 2 times 5i is 10i, 3i times 4 is 12i, 3i times 5i would be 15i squared. And now since I squared is negative 1, you have negative 1 times positive 15 to be minus 15, then 10i plus 12i is 22i, and then 8. No, 8 plus negative 15, or 8 minus 15 would be negative 7, so you have negative 7 plus 22i. Alright, now if you're dividing by a complex number, you would just multiply the denominator by the conjugate, because that will eventually cause the complex number to cancel out. Alright, so if you multiply the top and bottom by 5 minus 2i, with the bottom you would just FOIL. 5 times 5, which is 25. 5 times minus 2i, which would be minus 10i. Then 2i times 5, which would be plus 10i. Then 2i times minus 2i, which would be minus 4i squared. Then on the numerator, you'd have 3i times 5 minus 2i. If you distribute it on the top, it'd be 15i. And then 3i times minus 2i, which would be minus 6i squared. Then if you simplify that, minus 10i and plus 10i cancel out. Then minus 4i squared, that'd be I squared is negative 1, so negative 4 times negative 1 is plus 4. Plus 25 would be 29. Alright, I squared is negative 1, like we said before. Negative 6 times negative 1 is positive 6. Then plus 15i over 29. Now to get it into standard form, we split it up into separate fractions. 6 over 29 plus 15 over 29 I. Alright, so now for our second example, 2 minus 3i over 4 minus 7i. Alright, you multiply by the conjugate. Now, if you multiply a number by its conjugate, essentially what you can do, there's a shortcut when you do this to remember how it goes. You can square the first term, which is 4. Take this second term, which is 7i, square that, and just remember that will be a minus in the middle. Then it will be 2 minus 3i times 4 plus 7i. So, now if we simplify, it'd be 16 minus 49i squared. Then if you FOIL this stuff and simplify it, do it the way you did before, you should get 8 plus 14i minus 12i minus 21i squared. Now if you simplify the numerator, or the denominator rather, first. Now, since I squared is negative 1, negative 49 times negative 1 is plus 49, then you have positive 16, so 49 plus 16 is 65. And then 14i minus 12i would be 2i. Then that should be 21i squared at the end, not I. So I squared is negative 1, like what we said about 3,000 times already. Negative 21 times negative 1 is positive 21, plus 8 would be plus 29. So you have 29 plus 2i over 65. Now to get it into standard form, you'd split it apart. 29 over 65 plus 2 over 65i. Now, the third type problem I want to go over is whenever you have a 2i, or some number times I on the bottom, you have just the imaginary part. I mean, you could, technically, as a side note, you could rewrite 2i as a complex number, 0 plus 2i. So the conjugate would be 0 minus 2i, or just negative 2i. So you could technically multiply by negative 2i if you wanted, but you don't have to. There's another way you can do it. Since we don't have a complex number, we just have just the imaginary part, you can just multiply by I, if you want to do it that way. I mean, if you want to multiply by negative 2i, you can go ahead and do that in your notes and just pause here, or just stop watching here because it's the last example. Or you can do it this way, because I think in this instance it's a little bit easier. So you have 2i times I, which is 2i squared, then I times 4 minus 5i. So now, the denominator simplifies to 2 times negative 1, because of the I squared, which would be negative 2. And if you distribute the I, you'd have 4i minus 5i squared. Now, if negative 5 times negative 1 is positive 5, then plus 4i divided by negative 2. Remember, to get it into standard form, you'd split it into separate fractions. So you have 5 over negative 2, or negative 5 halves. Then positive 4 over negative 2, or minus 2i.